The importance of watershed management is to address all sources of pollution, and agriculture is considered a real concern. In the case of the Chesapeake Bay, we've seen a dramatic expansion of no-till production, that is land that no longer sees the plow. You no longer have the ability to work the manure into the soil. In doing that, you leave manure on the soil surface. Nutrients that are in that manure are released to the environment rather than delivered to the crop. And there's a real potential to increase the pollution load to the Chesapeake Bay.
The big problem we have with nutrients in agriculture, particularly here in the Chesapeake Bay Watershed, is not so much mismanagement on farms, but it has more to do with how our agriculture has evolved over the years, particularly our animal agriculture. We're moving large amounts of nutrients from one part of the country to another. And so they're accumulating in the areas where the animals are. So we end up with a big nutrient imbalance in the Chesapeake Bay region, and that's why we have the water quality problems we're faced with.
In order to address the issue, we're introducing manure injection and other means of directly incorporating manure into no-till soils without using the plow. We're looking to do on-farm research under real-world conditions so that we can get feedback from farmers, but also so that we can represent the array of conditions that farmers face in the Chesapeake Bay watershed.
We need better management practices for poultry litter because in the past, the only way to handle it has been to spread it on the surface of the ground. What we're trying to do with the poultry litter Subsurfer is to give producers options that allow them to put those nutrients down in the root zone of the crop. As much as 90% or more of the nutrient losses that normally occur in the runoff can be prevented by putting the nutrients under the surface. Fundamentally, this is a system of parallel augers that pull the litter from beneath the stack and grind it and crush it as they pull it forward to the front of the machine. And there, each auger drops it through a slot, and it has a set of double disc openers that open the soil, make a shallow trench about 3 inches deep and about 2 inches wide. We drop the litter down in that trench, and then it has a closing wheel and leaves the litter completely covered. If anybody wants to see where we dug up the litter, we've got some shovelfuls taken out here. You can see where it's under the surface.
The main benefits of injecting manure are that we can reduce a lot of the nitrogen losses through volatilization. We also have concerns with runoff of things like phosphorus. When you leave the manure on the surface, if it rains on it, it can carry those nutrients directly off of the field. And the other thing, frankly, is odor. And if we can get the manure incorporated, we can often take care of that also.
Farmers are under a lot of pressure with respect to meeting their nutrient management requirements. And one of the things that the Subsurfer would do would help farmers meet those nutrient management standards by reducing the amount of phosphorus and nitrogen that would move into water bodies due to overland flow. We've been able to show that it increases corn yields by anywhere from 25 to 35% compared to traditional surface applications.
One of the things we try to do with farmers is try to make their management more environmentally and agronomically beneficial. So what we're concentrating on in this project is to have a technology that is good for the farmer and good for the environment. So this helps water quality, it helps air quality, and it also helps the farmer's bottom line.
We're going to be looking at how can the farmers use it to grow the best crop? How far off of the row should we be injecting the poultry manure relative to the crop row? How does it influence what your side dress rate should be? Does it change from our previous method of broadcasting? So the real agronomic questions for the producers of how to best use this technology is what we're going to be looking at with the Subsurfer.
In New York, we have a heavy dairy industry, and we're going to try it out with composted separated solids. We're actually interested in using the Subsurfer in both row crop systems as well as in hay fields and potential pasture systems as well.
We've done some fairly extensive use and testing this, and for the hundreds of farmers that have viewed this machine, we've gotten a very positive response.
Have a limited amount. I've already had some growers that are into no-tilling that have heard about the Subsurfer, and they're excited about it and want to test it because they see that as a real benefit to be able to get that poultry manure down into the soil and be able to conserve all of the nitrogen.
I think that with any new technology, the biggest obstacle is just the fact that it's new. Farmers are really great innovators, so I'd really like to get the unit out there, let them kick the tires, drive it around the lot, and let them tell us what we need to do.
Our desire is to see the transfer of a very important technology to livestock operations around the Bay watershed. This project will only succeed with the participation of farmers. And if farmers are interested in participating in the project, all they need to do is to approach their local conservation district to see if there are opportunities to test the Subsurfer on their land.